Well, good morning, good afternoon, everybody. Welcome in from truly across the continent today for another exciting Exploring by the Seat of Your Pants broadcast. Many of you are new to us, and so if you are joining us for the first time, we are all about bringing conservation, adventure, and science into classrooms around the world. And you're catching us in a very exciting day for a couple reasons. Number one, this is the first of a triple header. We've got some amazing programs to come to wrap out the day today with neuroscientists and on sustainable future. So if you want to check us out, those programs, like all our programs, are going to be on our YouTube channel. So you can watch them in like 3 weeks or 3 years down the road. Lots of opportunity to keep the learning going. And two, it's very exciting because we are continuing our most epic series of the early school year. And that is with our friends at If Then She Can and Frontiers for Young Minds. So last year, we partnered with both organizations separately. Frontiers for Young Minds connects scientists with kids like you to write articles that kids can find accessible. They have got thousands of articles on their website. I can't encourage you to check it out enough. They are so cool. And we partnered with If Then, which is the greatest ever program showcasing the coolest women in STEM on planet Earth. They have 125 ambassadors on everything from astronauts to neuroscientists, cave divers, and more. And we have been thrilled to partner with them for 2 straight years on some epic broadcast series. Well, those two organizations partnered. We've been doing a 10-part series with them. We've got another program with Dr. Liz later today on neuroscience, so you can check that out and all the rest of this epic series right here. Now, before I dive in with today's speaker, I want to note we do have a Kahoot today. So between our talk and our Q&A, you can play along with a little 4-question quiz, have some fun, test some understanding. That is not the game pin. I brought the one up from yesterday. I'll get you all the game pin for our Kahoot in just a minute, but we'll have a little bit of chance for interactivity in the middle of the broadcast. Now today, I'm so excited because we are welcoming in Dr. Tammy Goulet. She is joining us to talk about clownfish and corals, two of the coolest creatures in the sea, her own experience in scuba diving, science, and more. She's got a really special thing that she got the chance to do for the If Then She Can Ambassador series. So I'll let her tell you that in just a minute. And I'll stop with my spoilers and zip my lip. I'm going to welcome in Dr. Tammy. Thank you so much for joining us today. And we can't wait to go on an underwater adventure du jour with you.
Thank you so much. Welcome, everyone. So I am an If Then ambassador, and they actually made full-size 3D statues of us. So if anyone wants to ask me about that later in the Q&A, I'm happy to also answer that. So today I'm going to talk about clownfish and corals. And I'm going to start off by saying that basically asking, right, are there natural live tropical corals in Mississippi? So I am in Mississippi. And the answer is that there are not. And so what I wanted to show you about that is that you can live anywhere in the world and even be in a place where there aren't any coral reefs nearby and still do research on coral reefs. So where am I? I am currently in Oxford, Mississippi at the University of Mississippi. For those of you that are interested, that is also the place where William Faulkner used to live. And if that doesn't ring a bell, Elvis Presley was born in Tupelo, Mississippi. So there's a lot of connections there. But I don't work in Mississippi. I work on coral reefs all over the world. The other thing that I wanted to bring out is a shout out to Canada and to show you guys, this is a picture of my family in Banff this summer. I wanted to point out that I have 5 children. And the reason that I wanted to let you guys know that is that whatever you pursue and whatever career you choose, you can mix and match and choose to have a family, choose to have a dog or cat family, but you don't have to give up one for the other. So shout out to Canada over there. And so where do I work? I work all over the world. So for example, I did a lot of work in the San Blas Islands in Panama. That is the area where the Kuna Indians work and own their land. I also work throughout the Caribbean. So this is a picture of a coral reef in the Caribbean. And in the Caribbean, I have worked, for example, in Puerto Morelos, Mexico, at the Marine Lab there. And I'm actually going to go back there in December. So as a coral reef biologist, I get to travel all over the world. And I'll show you a specific study that we did in one such area. This is a picture of Ceiba. It is an island in the Caribbean. And the reason that I bring Ceiba to your attention is in the port, they have a mural. And it's a very pretty mural. And if you look at the mural, it has a saying, and the saying says symbiosis, Nothing in this universe exists alone. So I'm going to talk to you about symbiosis. I work on symbiosis in the sea. So before we start talking about symbiosis, think about the fact that you may share a room. If you don't share a room, you probably share a house with someone, right? And so when you do that, when you share a room or a house, why do you do that? What are the advantages? What are the disadvantages? And for you guys, especially if you're still in school, why is probably you have no choice, right? You need to share a room or a house. You can't live alone. There are certain advantages, so you can have somebody cook meals for you, but there are some disadvantages. You may have to have responsibilities. You may have to clean your room. You may have to do some house chores. So there's a give and take when you live with other individuals, be it in a room or be it in a house. Well, symbiosis is similar to having a roommate or a housemate. The difference is that symbiosis, the definition of it, is it's a living together of at least two organisms from two different species. So although you may think that your brother or sister may be an alien, they're not, right? We're all humans. But symbiosis is when you have an interaction between two living organisms that are of separate species. And this definition was coined by Antoine de Barry way back in 1879. So what are examples of symbiosis? So for example, you may have heard of parasites. Parasitism is part of symbiosis. Mutualism is part of symbiosis. Commensalism is one of those in-between situations. So in parasitism, one organism is harmed and the other is benefit. And in mutualism, both of the organisms benefit. Now, I'm going to give you also a bit of information about these types of symbiosis. So you can have things that are symbiotic. So you can have organisms that are on the outside of the other organism, and that's an ectosymbiosis. So you see here a ray. So these are on the ray. You have these remoras that are attached on the outside. Or you can have endosymbionts, endo meaning inside. So you have, for example, in this case, you have an insect egg and you have bacteria that are within that insect egg. Then the last thing that I wanted to point out is that symbioses can be facultative, which means that at least one of the organisms don't have to have the symbiosis in order to survive, or they can be obligate. And what that means is that if they're not in symbiosis, they're going to die. So how does that fit in with coral reefs? Well, let me show you. So corals are, in this in particular case, so I'm going to talk about hard corals. Corals are basically creatures that live in a calcium carbonate cup. So the picture that you see with the fish is when the tentacles of the corals are inside their cup. And when you have a coral that dies, all you see, the remaining is the skeleton, and you can literally see that these are cups. And then the corals have these polyps, and those come out, and that's how they feed. So you have two types of skeletons. You have an external skeleton, which is a calcium skeleton, and you have an internal skeleton, which is water-based, which is a hydrostatic skeleton. So I actually did bring props. So I don't know if you want to see it on a full screen. So you have here, this is a cup, right? A regular plastic cup. And what I did was I put a glove in it. So you have a glove that is sitting in this cup. So the skeleton is actually on the outside, but the glove is sitting on it. And when you bring it out, this is like the tentacles. And so the tentacles, the way that they work and the way that their skeleton works is a water-based skeleton. So what I did here is I filled up a glove with water. And if I push on the glove, the fingers come out, right? And if I do not push on the glove, the fingers are relaxed. So you have these fingers. And so the skeleton is formed by the pressure of the water in the inside on the tissue of the animal on the outside. And then today we're going to talk about anemone fish, and the anemone fish live in sea anemones. So these are so what I have in the slide is corals. Now I'm going to talk to you about sea anemones, and sea anemones are basically a naked coral. So they're a polyp. They're only one polyp, and they have a hydrostatic skeleton. They don't have the hard skeleton. And then they fill up with water, and that's how their tentacles become firm and stretch out. And then the anemone fish, in this particular case, can swim within the tentacles. So both the heart corals and the sea anemones are part of the animal kingdom. They're part of a phylum that's known as cnidarians. And you have various groups in that cnidarians. These are known as classes. You may have heard of jellyfish. Those are part of the Scyphozoa stuff. You may have heard of hydra. Those are part of the hydrozoa. And then in the anthozoa, you have octocorals and hexacorals. And those in the hexacorals, you have the heart corals. So that's ones that I told you about. And then you have the sea anemones, the ones that I'm going to focus on. And then you also have octocorals, which are found throughout the tropics as well. And so I work on all of these anthozoa, but today I'm going to talk to you primarily about sea anemones. Now, before I do that, I'm going to tell you that heart corals, octocorals, and many octocorals and many sea anemones have a mutualism, right? A beneficial association with when both organisms benefit between algae. These are particular dinoflagellate algae. So you can see them here. They look like boring brown balls, and they live inside of the sea anemones and heart coral. So they're endosymbionts. And what they do is they do what algae can do, and that is they photosynthesize. So they produce sugars, and they provide those sugars to the host, in the case of corals or sea anemones. And then the coral or the sea anemone provides protection because the algae live within the coral or the sea anemone. And also they get the nitrogen, so they get the waste from the corals. So corals and sea anemones are animals, and they also go to the bathroom, like we do. And so they have, like we have urine, so we go and we have urine, and these guys also have nitrogen waste, and so they provide them to the algae. So this is a symbiotic relationship that is mutualistic. And so this is a picture of a coral polyp with the algae inside. And so you can see them because they are brown in color, while the coral polyp itself is clear, it's see-through. Now, with global climate change, there are certain challenges to coral reefs. So, for example, there are a lot of things that are stressing coral reefs out. And some of the examples of those are there are seawater temperature changes. So temperature is going up and even sometimes going down, and that stresses corals and other organisms on the coral reef ecosystem. Ultraviolet radiation levels are going up. There's this thing called ocean acidification, where the ocean is becoming more acid relative to what it used to be. And there's also eutrophication. That's a big word for saying that there's nitrogen and phosphorus. So sewage, for example, can spill into the ocean, and that can affect coral reefs as well. So as a result of all of these stresses, what happens in the coral reef ecosystem is this phenomenon called bleaching. So bleaching is when the algae leave or their photosynthetic pigments are lost. And as a result of that, because for corals and for many sea anemones and octocorals, the relationship is obligatory, so the coral has to have the algae in them, the corals die if they lose too many algae. So coral bleaching is a huge concern for the coral reef ecosystem. And although we think of corals as the ones that build the ecosystem, so it's an ecological system, right? There are many, many organisms in that. There are fish, there are sea anemones, and we're going to talk about those sea anemones. So you have here a symbiosis, which is an ectosymbiosis between fish and corals. And so that is a mutualism. And I'm going to talk to you right now about another mutualism with sea anemones. Now, you may think of coral reefs they are in the tropics, right? So they are in a very narrow band in the world of plus 30 and minus 30 latitude. But they're not necessarily by rainforests. There actually could be by deserts. So what I'm going to show you here, I don't know, so you can see a sign. It's a camel crossing. So on the way to my field site, you may encounter camels of all things. But then once you get there, the work is done in the Gulf of Aqaba or Gulf of Eilat in the Red Sea. So the Red Sea is the big tongue that you see here. And to the side of it is the Suez Canal. And then we're going to look into the Gulf of Eilat. So the city of Eilat is there. And what you see here is a picture of the waters. And you can see that it is a complete desert. But in the water, there is the rainforest of the sea, and it is full and teeming with life and teeming with fish and starfish and all sorts of different organisms. Now, in order to work there, I use scuba diving. Scuba is self-contained underwater breathing apparatus because as you know, we can hold our breath in water, but we can't stay down very long. And a lot of my work requires to be in the water at the level of the fish for an extended period of time. So I use scuba. And so I carry with me a source of air and I breathe through the thing that is attached to my mouth that is called a regulator. And if you've ever opened your eyes in water, you know that you see blurry. So I wear a mask and the mask has air inside the mask so I can actually see out. Now, I don't walk on the reef because if I were to walk on the reef, then I would actually hit things. So I have to stay and horizontal because I don't want to hit corals. And what I'm going to tell you about is the two-banded clownfish, and it lives in two different anemones in the Red Sea. It lives in the bubble tip anemone, and it is obligate for the clownfish. So the clownfish has to live in this anemone, and it is facultative for the anemone. So not every anemone has clownfish. And the other anemone that it lives in is the long tentacle anemone, which is a thinner anemone. So what we did was we went into the reef. And so you see here the pier and you see the map, and we mapped every single anemone that is found on the reef. And then we looked at whether there were anemone fish in those anemones. And then not only that, but what we were interested in finding out is whether there was any spatial patterns. So for example, you see here the adults are in red and the settlers are in pink. And you see that the adults, not every anemone is occupied, but the adults prevent settlers from settling around them. So they kind of have their territory and they make sure that others cannot go into it. The same thing is when you have new recruits. So these are new baby anemone fish that come in and they settle from the water. They actually settle away from the adults because they want to make sure that because the adults actually chase them away. So there are very clear patterns on the reef of where anemone fish are found and the various ages of where they are found. Now, what we did also, we did a study where we looked at the anemones and the anemone fish population from 1997 until 2015. So that's nearly 20 years. Now, what you can see here, that in 1997, there were a lot of anemones. There were actually a total of 199 anemones. But by 2009, their number was actually reduced to a quarter of that. So only 25% left. And in 2015, that number fell even further. And there were only about half of that. Now, this is the house of the anemone fish. So what happened to the anemone fish is the anemone fish numbers also dramatically dropped. And so there are fewer and fewer anemone fish on the reef, which is in line with having fewer and fewer houses. Now, what you can also see here is that the striped red bars show you the breeding pairs. So the number of breeding pairs, so these are the anemone fish couples that are on the reef, they stayed relatively the same over time, but the number of babies, the number of new recruits fell dramatically. And so what is happening on the reef is like the game of musical chairs. You may have played musical chairs in a birthday party. So what you do is you set up a line of chairs, and then you have the number of chairs is one less than the number of people that are playing the game. And then you play music, and when the music stops, everybody sits on a chair, but because there are less chairs than people, one person is left out, right? And that person has to leave the game. And then you take out another chair and you do it again and again and again until there is only one winner, because there's only one chair left. And so with these anemones becoming less and less, there's in some ways a musical chairs game where you are losing the houses. And so anemone babies do not have anywhere to settle into. And it may be a danger of having this whole population potentially crash. And so what my lab is doing is following this anemone and anemone fish population and trying to figure out what is going on, and hopefully trying to prevent that the whole system will crash. And then I wanted to leave you with the fact that you may have seen Finding Nemo, which is a story between a dad, Marlin, and it's his child, Nemo. I just wanted to say that there is a flaw in the movie, but if anybody wants to ask me about that, I'll be happy to answer that as a question. Okay, and that is what I have for you guys.
Well, Dr. Tammy, thank you for the tease for Finding Nemo. And it's dawning on me as you say this that like Finding Nemo is something that I watched when I was like 11 when it first came out, and some of our kids might not have actually seen Finding Nemo, which is really distressing to me as a grown man now. So kids, if you haven't seen Finding Nemo, get out there, do it. Dr. Tammy, if you want to exit screen share, I know it may be a bit finicky to do that, then you can see us again. Awesome. We are going to dive in by starting with our Kahoot, which I actually have the proper game pin for now. So if you want to join in with this, please do. You can bring it up as a separate tab. For those new to Kahoot, the faster you answer, the more points you get. And what you win is Dr. Tammy and I's everlasting respect. So that's what's on the line. No pressure at all. I'm going to bring this up in just a second. And as I'm doing it, I want to note that in addition to being a quick and fantastic overview of so much of coral and anemone and science, it is also the most that anyone has ever used the word anemone in a 20-minute period in world history. And if you can pronounce it correctly that many times in a row, you deserve to be a scientist on it, because that is a really tricky thing to do. So there's so many of you in our Kahoot. Awesome. Keep coming in. Keep coming in. I'm going to get us underway in just a second. And then we are going to head for our question period. So, Mr. Bedard, you are going to be first with your Calgary crew, and then we're going to go through the lineup. So if you're here, trust me, you are going to get a question in. There's so many classes, which is amazing. All right. Dr. Tammy, I'll say too, is if you want to help us out with hints on any of the Kahoot questions, you are welcome to chime in and give us some assistance as we get underway. All right, here we go. 3, 2, 1. Question 1. Is coral we talked about this in the middle. Is it an animal, a plant, a rock, or an alien? It's very strange. Coral is an odd creature, odd thing, perhaps. But it is at base one of these, even though it sort of touches upon a few of them in a variety of ways. 60, 80. This is our biggest Kahoot in a while. You guys rock. All right. It is a animal. So a lot of you thought plant, but at its heart, it's related to things like anemone. It's related to things like jellyfish. It is an animal. It just has some plant-like characteristics, shall we say. And
it also has a plant in it. So it has an algae in it. So, yeah.
That may come up in question 2. So coral animals have algae growing inside them that help them photosynthesize and give them their color. True or false? It's just been given to you. This is like a freebie. What do we think? It's got a really interesting name. I'm going to bring up a banner with the name for the algae that live in coral right now, because it's a really hard one to spell and say. You don't see it very often in your everyday life, but they do indeed. So the answer is true before it reveals it. And they're called zooxanthellae. So they're a really cool name. That was my tricky word when I used to work at the aquarium in Toronto. Zooxanthellae. All right. Red Rhino has our lead as we go into question 3. This was not specifically mentioned in the talk, but I love highlighting it. So this is our third one. So you talked about how cool scuba diving is, and scuba diving is the best. It opens up 70+% of the world to you in a way that you simply can't explore if you don't have that skill. How old do you have to be to start scuba diving like Dr. Goulet? 20, 25, 15, or 8? I just got my certification a few years ago. Oh, this threw off everybody. The answer is 8. Only 3 of you got this right out of the 80 of you. So that sounds crazy, but pretty much everyone in our audience today, you can start scuba diving. So Patty Bubble Maker is the name of the way that you can do this. And you can literally have a scuba apparatus underwater in a pool. By 10, you can get your first full scuba diving certification. So the same thing that I have, you can do at 10 years old, which is crazy. And if you're in like Iowa or Saskatchewan or Oklahoma, like some of you are today, you can still go scuba diving. You don't need to be on an ocean. There are pools and quarries and lakes and everything else. Like the world is your oyster to get this skill. So keep that in mind as we go to question 4. What can we do to help coral reefs? This is true for anemones. It's true for pretty much anything. Is it choose sustainable seafood, work to reduce our carbon footprint, dispose of garbage properly, or hint, hint, nudge, nudge, all of the above? Which may be the answer in a lot of my cahoots if you've ever joined me before. Let's see, 95. Are we going to get 100? We have 100. 100 cahooters. That's the biggest in so many. Nice. You guys rock. Okay. Let's see what that does to our leaderboard. Then, Mr. Bedard, we're coming to your virtual school in Calgary to kick us off. 3rd place is Gentle Lemur. 2nd place is Expert Pony. And first, for all the marbles, drum roll please, barely by 4 points, is Dr. Griffin. All right, if you did play along, thank you so much. That was awesome. You guys rock. And now, all right, Tammy, we're going to dive in with our Q&A. So, Mr. Bedard's group, come on in and take us away, man. Hey.
Oh, hello, can you hear me? Can you hear me okay?
Yes, you're good.
Hello. Hi, Dr. Goulet. It's an honor to learn from you. My question focuses on women in science because historically, you've been underrepresented in STEM fields despite your contributions. So what advice would you give to students, especially young women, who are interested in pursuing careers in marine biology or STEM fields?
Amazing question. Thank you.
The short answer is believe in yourself and be an advocate for yourself, because people are, sometimes there are roadblocks, right? And you need to have, in some ways, the courage, but it's mostly saying, I can do it. Yes, I can. Right. And the other thing is, it is wonderful to have allies, right? People that can help you along the way. And if you find them, then definitely embrace that, right? Because having support is important. But the biggest thing is to realize that you can do it, and it will happen.
Yep. That's a beautiful first question. Thank you for the answer, Dr. Goulet. And I do want to stress again, I put this in the chat for everybody, but ifthenshecan.org, truly like the best resource of all time. If you're a girl, if you're a boy, if you're anyone who's interested in getting into STEM, it's like the greatest group of ambassadors with learning resources I've ever seen for any program in the world. So do check that out. All your teachers will get that in an email at the end of the broadcast as well. So cool first question to kick us off. We're going to head to Mrs. Sykes' fourth grade class for our next question. So come on up and take us away, guys. Hey.
I have a question. I'm going to have Bert come on up to ask.
Awesome.
Is there a lot of pressure when you go really deep to the coral reefs?
Cool question.
Yes. So for every 10 meters, so that is 33 feet, you have an increase of 1 atmosphere pressure. So there is pressure. And actually, if you've ever been on a plane, or sometimes you have your ears get plugged, basically pressure creates a situation where your eardrum pushes in. And so we literally, when we go down, we have this thing where you have to equalize your ears. So you literally have to stuff your nose and do a little blow in order to equalize the eardrum. So yes, the pressure does increase as the deeper that you go. And yeah, it does definitely affect you. I want to add one more thing, that light attenuation changes. So for example, if you get a prick in your finger and you're actually bleeding underwater, you might see your blood being green and not red, because the light the ability of the light to penetrate the water changes with depth.
Yeah. I've actually had this happen when I went scuba diving. I cut my hand on some zebra mussels once, and it's really weird to see green blood coming out of yourself. So the moral of the story is try not to cut yourself underwater because it's bad to do that anywhere, but it's really cool if you do. It's an interesting look. Great question, guys. All right. St. Luke's, grade 6, 7s. I know you guys are a voice in the ether as opposed to on camera, but if you want to unmute your mic and come on in. Oh, you are on camera. Perfect. Even better. Hello. Hi, guys.
What are the statues made of, and how do they make the statues?
Yes.
That is a really excellent question. So the statues are actually made out of plastic. And as you saw, they are bright orange. The way that they made it, they had us walk into a booth that looks like a cylinder, and we walked into it, and they scanned us 360 degrees from all around. And they actually had a challenge with scanning me because, as you saw, I showed up with my masks and my fins and my snorkel. And when you do a scan, you can't have anything pointing out. So everything needed to be flush against my body, which is why the fins and everything are situated the way they were. And so I had to stand perfectly still while the cameras were going around me. And then they literally 3D printed it. So they printed one layer at a time. So you can actually see the ridges of the layers. And they were they showcased the statues at the Smithsonian Institution in Washington, D.C. And people got a chance to walk around and see them.
They are so cool. I'm so glad we got a question on the statues. We actually haven't had a statue question in any of our other If Then programs, so I really appreciate that, St. Luke's. Quest Montessori, we're going to head to Rhode Island. If you guys want to come up with a question, you are good to go. Hi, guys. Welcome in. Hello.
Hello. Why do the adult clownfish keep the baby clownfish out in their food so the clownfish community gets lost and many eventually die out? Why don't they share?
Why don't the clownfish share? If you caught that, Dr. Tammy, yeah. Why do they kick them out?
So the in this particular anemone fish, you have pairs that are adult pairs that are bonded for life, and so they form a couple, and they stay in their anemone, and that's their home. So they protect that anemone from and the area around it in a way, and kind of their territory from other fish. Now, one thing that I didn't mention, so I'm going to mention that really briefly. The anemone fish lay their eggs at the base, at the bottom of the anemone. So the anemone itself also protects the babies. But once the eggs basically hatch and they leave, there's no more taking care of them. So while they're still eggs, the male fans the anemone fish eggs, make sure that they're fine, that there's no algae growing on them. But once the babies hatch and leave, there's no more bringing them back to the nest. So the anemones basically they're very territorial. They protect their territory. And if it's one of their own species or any other animal, they're going to chase them away. And so they don't share. But the anemone babies, when they settle, you can have more than two in an anemone, and you can have then juveniles, which are slightly bigger, right? Kind of teenagers. You can have those with the babies, but not the adults.
One of the ways of thinking about it is that different animals have different strategies. People, we're really used to ourselves, where it's like, let's stay at home and be together forever. And most animals aren't like that. There's a lot of different strategies for making a living out on the reef and in the rainforest and anywhere else in the world. And so you'll find that are things that sound kind of weird to human ears are things that a lot of animals do with their young. So great question, guys. All right, let's see. Mrs. Jones's class, come on up and take us away with a question. Hey, guys.
Don't sit down. I already picked somebody.
Is it true that when a female clownfish dies, the male will become the female?
Cool question.
Excellent. So yes. And so if you do end up watching Finding Nemo, what happens in that movie, you have Marlin and his wife, and they lay the eggs, and then the mom is preyed upon and vanishes, and all the eggs are destroyed except Nemo. Now, if that were to happen on the reef, Marlin wouldn't stay Marlin. Marlin would become Marlena, because the biggest fish is the female, and all the babies are born as males. And when they settle, when they join an anemone, if there is a female there, then you have the male already. But if the female is taken away, then the largest male will become a female. So you have sex changing in this species.
That's amazing. And I'm so glad that we had a question that led to your query. You set us up for the problem with finding Nemo, and we got to answer it without even explicitly asking. So way to go. Thank you, Mrs. Jones' class, and for doing cool research on a species before the broadcast. You rock. That was great. We are going to head to Mr. B's class. There's so many of you. I love this program. Come on in and unmute your mic, and you're good to go. Hey.
So what is it like scuba diving in the water?
Yeah.
It is amazing. First thing is you get to be in a place that and be at eye level, right? Literally looking at these guys from their own point of view. The other thing is there's a lot of senses. So when you are breathing through this regulator, when you exhale, the air that you're exhaling comes out as bubbles. So you hear blah, 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 right? And so it's very relaxing because when you inhale, you hear, and when you exhale, it's like, boom, 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 boom. So it kind of makes you calm down and relax and look around. And then you have fish that come really up close to you. So you're really one with nature. So it's a very pleasant and exciting experience.
It is one of the coolest things you can ever do. And again, most of you are at an age that you can go do this right now. So truly, like when you're done today, leave your class and go learn scuba diving because it's one of the best things out there. So I'm so glad we got that question. Thanks, man. All right, let's do. Time flies and you're having fun in these broadcasts. I wish we could go all day with your questions, but I will note if you've got extra questions for Dr. Tammy about coral reef, about scuba diving, email them to us at exploring by the seat of your pants, and we'll try and answer absolutely everything after the broadcast is done. Got time for about 3 more before we wrap up here. So we are going to go to Mrs. Hanley's class. Unmute your mic and take us away. Hey. Oh, where'd you go? There we are. Sorry, go for it.
The other animals that beside clownfish that are adapted to live in anemones.
It's so hard to say. Good for you for trying. So any other anemone creatures?
Yes. So you have you also have shrimp that sometimes are in the anemones, and in corals as well. You also have crabs. So there are other animals that are living on the inside and on the outside of these guys. But anemones, it's mostly shrimp. In corals, you have crabs. You also have boring bivalves. So those are shelled animals. And then there are animals that come and go, but don't necessarily live within these with either corals or sea anemones.
Yeah, we actually never had that question in any of our broadcasts. So thanks for that, man. All right, I'm going to take 2 more from online. A few of our classes' devices are off. If you want to share in the chat, we'll try and sneak them in before we wrap. But the wonderfully named Sawyer Eaton on YouTube wants to know, when did you start scuba diving? When was your first dive?
So I started scuba diving in 1988. So that was a while back. I was 21 at the time. And I loved it so much that it actually, affected what I chose to do. And then I also took advanced dive courses. So I'm an assistant diving instructor. And so you learn, and then I'm a scientific diver. So you have to have specific training to be a scientific diver, because when we work on the reef, we don't want to destroy the reef, right? So we need to be very buoyant. We need to maintain ourselves and not sink down on the reef itself.
Very, very cool. We've got people that are at every level of diving. We've got like the best cave diver in the world who regularly comes on the broadcast. So basically, if you're keen on diving, check out our YouTube channel, because there's like a million amazing people that have explored the underwater world in pretty much every way you possibly can. A very easy one to wrap up with. And again, I want to stress for all our kids, if you want to check out the rest of our series, it's online here. I'll pass this to all your teachers. IfThenSheCan.org is great. Kids.frontiers.org has amazing articles, including one with Dr. Tammy. So lots to explore and discover there. To wrap, just the question, is there any specific rare exotic fish or really cool creatures you've seen while scuba diving that you want to share with us today?
Yes, I have. Before I forget, the research that I spoke about actually is in a Frontiers for Young Minds article. So if anyone's interested, that they can look at that as well. I have seen a lot of amazing things while scuba diving in Egypt. When I was diving in the Red Sea, I saw huge wrasses. I've seen turtles. I've seen sharks. I've seen seals that have come down and nearly taken my slate, what I write underwater with. You never know what you're going to see, and you have to be careful too, because there are some you have to respect the creatures, and there are some creatures that could pose a danger. So you have to always be aware of them, but they're awe-inspiring, every single one of them.
There's no better message than that. We love to feature amazing conservation wildlife programs here at Exploring by the Seat of Your Pants. So really, if you get the chance to go outdoors, if you get to go to amazing places like Dr. Tammy, dive on amazing reefs in the Red Sea, please do. But even if you just get the chance to explore your schoolyard or backyard today, there are amazing things out there, I absolutely promise you. And I just want to say a huge thank you to all our classes for joining today. Dr. Tammy, if you want to stick around with me when we're done the broadcast for a minute, that would be awesome. But what we do to wrap up every show is I'm going to bring in all our classes to say a huge thank you and farewell. So Quest Montessori, St. Luke's, Mrs. Sykes, Mr. B, Miss Hanley, Mr. Bedard. There's so many of you. Thank you so much, everyone. Have a wonderful day.